All right, and before we start solving radical equations in 10.7, let's back up for just a second and go back to just regular equations. So let's say you had something like 2x plus 3 equals 7. Okay, if you had just, and again, before we do the radicals, we'll go back to the basic one here. Remember, for these, most of the time, you've got to get the x by itself, so you've got to get rid of the positive 3 and then the times 2. And to do that, you're going to do the opposite or the inverse operation. So first thing is you'll subtract 3 from both sides. And again, the plus 3 minus 3 knocks itself out, so it goes to 0, which is what you want, so that one's gone. You know, with 2x equals 4, the last step then is to go back and divide both sides by 2. Okay, the only thing that's different with radicals when you're solving radical equations, if we're doing square roots, is that it's still kind of the same thing for this setup. Is what you've got to think about is we're going to have some kind of square root in here somewhere. So I guess the question you kind of have to ask yourself, and you don't necessarily have to write this down, is what cancels a square root? So what were we doing before in the last couple sections? What would cancel out a square root? Squared, right? Yeah, so if you have square root of x equals 10, you just square both sides. So yeah, you're going to take the square root of x equals 10 and square the left side, and you square the right side. So as long as you're doing the same thing to both sides, that's what you're looking at. So where you have the square root of x squared, those would cancel each other out and just give you the x, and then do 10 times 10 to make it 100. And the good thing about going in this direction is, in the past, you know, we had some questions where we had to vary the plus or the minus. When you're squaring it, it doesn't matter whether you square a negative or a positive, you're always going to get a positive answer. So for this one, it's just the one answer. You don't have to worry about any plus or minus signs when you're going through these. Now, here's kind of the big thing. We kind of got that before we got there. When you're going through these, here's the big thing you have to kind of remember. Or this is the one thing you've got to make sure of. Before you square both sides, so it takes a square number to do that, or again, we're talking about that, it's just second power. Before you square both sides, you have to get the radical by itself. Because if you don't, then technically you have to do the full method. And if you're doing the full method with radicals, it's usually not very pretty. And then you wind up with more radicals in your answer. So that's the one big thing you have to make sure of when you're going through these. Okay, so let's give you some examples where you actually have to work these out just a little bit. All right, so let's say you have 1 plus the square root of y is equal to 4. Okay, so this is really the only one rule you have to worry about when you're going through this one. This square root's got to be by itself. And you've got this 1 that's in front. It's a positive 1, so you have to subtract 1 from both sides. So 1 minus 4 is 3, so you've got the square root of y is equal to 3. And when you square both sides, when you get y equals 9. Okay, so once you get past that part, everything else is still doing that same thing. That if you're going to solve the equation to get the square root by itself, It's still the same order of operations that you would do with everything else. Do your addition and subtraction first. Once the addition and subtraction is done, then you can start moving to the multiplication or division. Okay, let's go with square root of p minus 4 minus 7 equals 1. Now, you've got, in this case, you've got not just the x on the inside or just the one variable. This time you've got p minus 4 on the inside. But it's still that same thing, that what you have on the inside, the square root, all that's together. So that's just one big expression. So all you have to get rid of is the negative 7. Just add 7 to both sides. So you've got the square root of p minus 4 equals 8. Okay, now, and again, even though the p minus 4 is on the inside, the square root is there. There's nothing on the outside the square root. So I guess that's the big thing you're looking for. Is just make sure, you can have more stuff on the inside, but make sure there's nothing outside that square root. And once it's here, then you're just going to square both sides. The square root of p minus 4 is going to be equal to 8 squared. Okay, so the square and square root cancel to get p minus 4. 8 squared is 64. And because there's that extra stuff on the inside, now you've got one more step to go from here. That now you've got just a regular equation to solve, so then you can add 4 to both sides. We got p is 68. Okay, let's go on here. Again, a little bit different, but along the same lines. So let's say you've got 4 is equal to the square root of 5v minus 9 plus 1. Okay, so there's the square root that we're looking for. So for this one, all we've got to do is get rid of the plus 1, so go minus 1 on both sides. Okay, so doing that, you've got 3 is equal to 5v minus 9. Square root's all by itself on the right-hand side, so then we'll square both sides. And when you do 3 squared to make it 9. And again, the square root cancels, so that's just 5v minus 9. Okay, and then back to another one where you got your two-step equation here, so you've got to get rid of the negative 9 that's with the v. And then just divide both sides by 5, so v would be 18 over 5. Again, if it's in fraction form, as long as it's in simplest form, that's okay. I mean, if you want to go back and change it to a mixed number, you can, but they should let you leave it like that. They won't have you make it to a decimal number or anything, so you can just leave that as 18 over 5. Okay. And the only real thing you have to kind of watch out for is whatever you have here, whatever the expression is. We'll just say you cannot have a square of an expression equal to a negative. That if you get the square root by itself, and whatever the expression is that you're looking at, if that equals a negative number, it doesn't matter what you have in there. If it's square root of x equals negative 4. Doesn't matter what it is. But if it's square root of anything by itself equal to a negative number, there's going to be no solution. So just like it was in the earlier parts when we were working with the square roots and the radicals and all the things there, that if you have a square root equal to a negative number, then you can't do anything with it. And they'll sneak one of those in on you every now and again as you're going through these. And it's one of those things where when you first look at it, it may not look like there's anything to it. So you may have something like this where you have 5 is equal to the square root of 2x plus 1 plus 10. And again, you have to kind of get past the first part of it, because right now everything's positive, we're good to go. But as soon as you get the square root by itself, when you subtract the 10 from this side, it leaves you with negative 5 equal to square root of 2x plus 1. That as soon as you get to this point, that's when you can stop and just say that there's no solution. And here's the thing, when you do this, you can actually, if somebody was to go back and solve this and square both sides, just to show you, you could go back and square both sides and get an answer. It's just not going to be the right answer that you're looking for. That if we had this thing, if we squared the negative 5 squared, you get 25 equals 2x plus 1. Subtract the 1, get 24. You get the 2 times x, you get x equals 12. Okay, you get a 12, but when you go back and plug it back in, 2 times 12 is 24, plus 1 would be 25. But when we're talking about square roots, that again, most of the time we're talking about a distance or some kind of thing, so for that part, you want the answer to be positive. So you would get an answer, it's just it's not going to make this thing work out to be like they're looking for. Okay, so if you get one of those where, that again, you get the square root by itself and it's negative, that's the part you can just get rid of it. Okay, and then next thing they're going to have you do, still solving with the radicals. It's going to give you something just a little bit different, but it's actually not too bad. So this time you've got 2 square roots. You've got square root of 7x plus 6 on the left-hand side and square root of 5x plus 16 on the right-hand side. And as long as you have 2 square roots and they're just one on the left side, one on the right side, there's nothing added or subtracted to it, then all you have to do is just go ahead and square both sides. Because when you square root this square root on the left-hand side, the square and square root cancel. Same thing on the right-hand side, the square and the square root would cancel. So you'll be left with 7x plus 6 and 5x plus 16. And from there, it's just a regular solving equation. I would say get rid of the 5x on both sides for the first step. And then subtract the 6. And then divide by 2. So then you get x equals 5. Now, on some of these, this is where sometimes they'll tell you that you have to go back and check. Up to this point, everything's good so far. You don't have to worry about checking any answers because everything should work out. If we get to one where we need to do it, it should have some directions on it other than just solve. Because they usually try to give you a hint when you get to one like that. Okay, so there's one where you have two square roots. And here's where they change things one more time. Still going to say solve, but the difference on this one is that instead of it being squared equal to a number, now you've got squared equal to a variable. And first step is going to be the same way. You're still going to go ahead, now the square root's by itself, so we're all good there. First step is you're still going to do the same thing. You're still going to square both sides. Square and square root cancel, so you get 7x minus 6. On the right-hand side, though, it's not a number, so it's just going to stay x squared. Okay, if you get one like this where you've got the variable, then what you've got to do is, at this point, you've got to get everything on one side of the equation, and in your x squared term, depending on where it is, you want that one to be positive, just because it's going to be easier for what we're going to do. So we're going to move both of these numbers over to the right-hand side. And we'll do them together. So we'll do minus 7x to get rid of this one, and then we'll do a plus 6 to get rid of that one. So you've got 0 is equal to x squared minus 7x plus 6. And does that look familiar? Maybe a couple of chapters ago. That for this one, you're going to have to solve this part, and you're going to have to do some factoring. There you go. So you're going to have to find the factors of positive 6, where the sum is going to equal negative 7. So this one's getting you ready for the final exam that's coming up, so they're going back and reviewing your factoring here. The good thing is with 6, there's only two choices. It's either 1 and 6 or it's 2 and 3. And the only way you can get negative 7 off this is if both of these numbers are negative. So when you factor it, you've got an x minus 1 and an x minus 6. And again, they're simple equations, so when you set both of these equal to 0, add the 1 to both sides, and you've got to add the 6 to both sides. And this is the one time, when you get two answers, this is the one time you have to check, because when we squared the x back here to get x squared, back in that very first step, when we get to this point, the original problem, we only had x to the first power, so we're looking for one solution. When we squared it, we've got x squared now, which gives us two solutions. So there's a good chance that one or maybe both of these may not work. So this is where you have to go back and check. And you've got to go back to the original problem to check it. And the original was what? Square root of 7x minus 6, no, plus 6, minus 6 equals x. Okay, so we'll start with x equals 1. We're going to plug it back in and see what we get here. So we've got the square root of 7 times 1 minus 6. And then the question is, does that equal 1? Well, 7 times 1 is 7. 7 minus 6 is 1, so does 1 equal 1? Yeah, square root of 1 equals 1, right? So that one's good, so it does work. And then we'll do the same thing with the 6. We're going to check it and see if it works. So plug it in the 1. We've got 7 times 6. Minus 6. And then the question is, does that equal 6? Okay, 7 times 6 is 42. Minus 6, that's what, 36? So does the square root of 36 equal 6? It does, doesn't it? So in that case, they both work. So get a yes and a yes. So your final answer for that one is both of those two answers. So sometimes when you check them, you get a yes answer on both. Sometimes you get a no answer on both. Sometimes you get one yes and you get one no. So it just depends on the numbers and what you plug in there and how you get through. And the good news is when you're doing these, most of the time the factoring should be easy. It shouldn't be anything with real hard factoring when you're going through these. They might sneak in one question where you have to do a little bit of bottoms up, but most everything factoring-wise should be that when you're doing these, should be that you're only going to have to factor x squared. I don't think they'll put anything with a 2 or a 3 or a 4 in front because that just, that ups the level of difficulty when you're going through those. All right, and then the last couple of things that you're going to get out of section 7 is they've given you some other problems that's here. Had you go through some different things. They're going to change it where instead of doing square roots, they're going to give it to you so that it's greater than 2. Give you third roots, give you fourth root, might even maybe give you a fifth root. Probably more than likely it's going to be third or fourth roots. So let's say you've got the fourth root of u equal to 3. So guess how we're going to get rid of a fourth root? Opposite of a square root was the squared power. So opposite of the fourth root, we're going to do the fourth power. There you go. So whatever the root is, or the index, you're just going to do the same thing on that part to the power. So we're going to do this to the fourth power and do this to the fourth power. So it's the fourth root of u to the fourth power equal to 3 to the fourth power. And again, your fourth power and your fourth root cancel each other out just to get you a u. And for this one, just do 3 to the fourth power. Should be 81. Again, they tell you to technically go back and check it, but as long as you don't have the x squared term, everything for what we're doing here should work out to be okay. Let's go with fourth root of 3x plus 4 plus 6 equals 8. All right, and the concept's still going to be the same as for the other ones. You've got this fourth root of this power back here. The first thing is you've got to get rid of this plus 6. So you're going to subtract 6 on both sides. So you've got the fourth root of 3x plus 4 equals 2. And again, because it's fourth root, do the fourth power on both sides. And again, the fourth power, fourth root, cancel each other out to get 3x plus 4. to the fourth is 16. Yeah. And then from there, just work it out the same way. You're going to subtract 4 from both sides. So you got 3x equals 12. Take the 12, divide it by 3, and then you get x equals 4. So the concepts are all the same thing. Whether it's second root, third root, fourth root, fifth root, doesn't matter what the problem is, as long as they give you a root just to undo it, whatever the index is or whatever the root happens to be for that problem, just do it to that power on both sides once you've got the root by itself, and then everything else after that should be just a regular solving equation. Now, let me show you one more thing, because this one didn't pop up in the homework, but talking to some people last time, I think it's one of those where sometimes they stretch you out to kind of advance you out to another part. So I don't know that this will pop up necessarily, but just on the case that it might, let's throw it out there to you just to make sure you can see it. So I guess we'll call this an extra one, just in case. I don't know if it'll show up for sure, but I think last time some people got this kind of problem, but some people didn't, so we'll just make sure. Okay, first setup part, still the same way. You've still got the square root here. You've got to get the square root by itself. So first thing is you would add x to both sides. So we've got the square root of 4 minus 5x equals x plus 4. And again, anytime you do this and you get the square root by itself, if you've got a variable on the other side, there's always a degree of difficulty this thing's going to go up in. So for this one, you're still going to do the same thing. You're going to take both sides and square it. So you've got square root of 4 minus 5x equals. Now, the right-hand side, here's where you've got to be careful, because it's not just x and the 4 that you're going to square. It's the whole side that's squared. So it's x plus 4 squared. So the square root and square cancel each other out to get 4 minus 5x. Now on the right hand side, don't get in too big a hurry. It's not just x squared and 16. Because if you do that, you've only done the fluff method. You've got to do the full method. So for this side, you've got to go back and do x plus 4 times x plus 4. Sometimes people get a little bit happy and they'll just square the x and square the 4, which is halfway there, but halfway correct, but also halfway wrong. That you've actually got to go back and do the full method here. So for that part, if you do the full method, you've got x times x for x squared. You've got x times 4 for 4x. You'll have another 4x. And then the 16. So you will get x squared, you will get 16, but you've got to add the middle two terms together to make it to be 8x. And now it's where it's kind of similar like it was last time. You've got the x squared term here that you want to keep positive. So you'll get rid of the 4 and the 5x. So we can add 5x to both sides. And you can also get rid of this 4 by subtracting 4 on both sides. So moving everything to the right-hand side where you've got the x squared, you've got x squared plus 13x plus 12, and now you're back to the same factoring that we had earlier, that you're going to find the factors of 12. And the good thing is they're all positive, which again makes this one a little bit easier. The factors of positive 12 where the sum is going to add up to be positive 13. And as soon as you do the first one, that's the number you're looking for. It's got to be 1 and 12. And because they're all positive, then the factors have to be positive. Now, solution-wise, they'll change because if you let 0 equal x plus 1, to get this one by itself, you have to subtract. So x would be -1. Same thing for this one, you're going to have to subtract, so x would be -12. And somebody's saying, we have two answers, do we have to check it? Absolutely, because you never know when one of these is going to work and one of them is not going to work. Okay, and I've forgotten what we started with. Square root of 4 minus 5x equals 8 plus 4. Okay, there's probably a good chance that when you do this, one of these, especially with negative answers, there's probably one that's not going to work. What's that? Oh, did I get it wrong? Square root of 4 minus 5x. Oh, minus x equals 4. Okay. Yeah. There we go. Okay, so square root of 4 minus 5x minus x equals 4. Okay, so we'll start with a -1 first. So if we plug in the -1, again, when you're not sure about numbers, I'd say put them in parentheses. So you got 4 minus 5 times the -1 minus -1. And our question mark is, does that equal 4? The good thing is you've got a -5 and a -1. So that is 4 plus 5. And I'm running out of room because we're at the very bottom of the page here. That's minus -1, so that's a plus 1. Square root of 4 plus 5 is 9. So square root of 9 is 3. And does 3 plus 1 equal 4? Yeah, we're good. So that one checks. And then we'll do the same thing with the -12. And we'll start a little higher for that one. Okay, so for this one, we're plugging in -12. So we have 4 minus 5 times -12 minus -12. And does that equal 4? Okay, with the square roots, we have 4. -5 and -12 is a positive 60. So that's the square root of 64. Minus the -12 is a plus 12. So square root of 64 is 8. Does 8 plus 12, does that equal 4? Doesn't, does it? Because you got 20 equals 4. So for this one, that one does not work. So that answers out. So we only have one solution, and that's at x equals -1. There you go. There's Happy Land. Okay, now again, I don't know that that will necessarily pop up, but there's a good chance that you may get that one where you have to do the full method on one side. And again, that only happens if you have x plus or minus something on the right-hand side. If it's just x, you're going to have to go back and factor it, but in that case, if you've got the two terms, then you've got to do the full method and go through the steps there.